Hi everyone, my name is Wade Desir, and this summer I interned at Plexim. My main focus is creating a support package for the ATmega328, which is more well known as the backend controller used in the Arduino Uno. This was a great experience because not only did I get to learn a ton of new things while creating the support package, because I also got to meet the wonderful people that work here, got a great introduction to how life works in the engineering field may be like. Enjoy the video. Welcome to the PLECS Model of the Month series. This month, we'll be looking at a support package that was created for the ATmega328. The ATmega328 is an 8-bit AVR microcontroller developed by Atmel for use in embedded systems. It features 14 digital I/O ports, 6 analog inputs, 6 PWM outputs with 32 kilobytes of flash storage and up to 20 MHz clock speed. Our next Model of the Month video could feature your model. If you have a PLECS model you're willing to share, send it to info@plexim.com with a description of the power stage and controller. If your model gets picked, we will make a video of it and post it to our LinkedIn and YouTube pages while publicly crediting your work. Let's start by talking about the PLECS Coder. The PLECS Coder is able to generate C code from PLECS model, but in order to generate the code, it requires a support package. The ATmega328 support package consists of a coder.lua file which handles the information coming from the PLECS model and uses that information to write and configure the correct function calls to the generated C code. The support package also has an ATmega.lua file, which checks the information coming from the PLECS model and correctly configures the settings.h file and the make file that will run the compiler and uploader. For example, each PLECS block has a subsystem that contains Lua code that runs every time that a model is simulated or built using the coder. The code in the block's subsystem runs and passes the user inputted information to the coder.lua file by storing the information in tables that it can access. Coder.lua then takes that information and outputs it into a C file. The generated code is mostly function calls that call on pre-written C files that I wrote specifically to be able to work with the generated code from PLECS. After running the Lua files and generating the C code, PLECS runs a makefile that then runs AVR-GCC to compile the code, and then the makefile runs AVR-dude in order to upload the code to the board. Let's start by taking a look at the blocks that are currently available for use. We have a digital in, digital out, and a PWM out block. We can take a look at the digital out block first. This block will take an input of either 0 or 1, and depending on that input, will output a high or low signal to the selected pin. Let's try it out. First, let's tell the block to output the signal to pin 10 of the Arduino. In order to set the pin high, we can use a constant in order to send a signal of 1 to the block, which will set the pin of the Arduino high. There's a green LED attached to pin 10, so hopefully we'll see that turn on. Let's upload it. So right now, these settings are for the Arduino Uno that I have on the right, but usually you might have to tweak these a little bit, change them so that they match your board or microcontroller that you have set up. Great, we got the LED on pin 10 to turn on. Now, let's take a look at the digital in block. This block will read the input signal from a specified pin. We'll set the pin to digital read on pin 13. Let's connect it to a digital out block assigned to pin 7. Now, when pin 13 goes high, then pin 7, which is connected to the output of digital in from pin 13, should also go high. And we should hopefully see an LED connected to pin 7 light up on our Arduino once we upload the code. Before we upload the code, however, let's take a look at our PWM out block. With the PWM out block, you can choose which one of the ATmega's 3 built-in 8-bit timers you want to use in order to output a PWM signal on the corresponding pin. The output pin is based on which timer that you choose. And you have 2 modes to choose from, inverting and non-inverting. In non-inverting mode, you may choose a pen and a prescaler, and a square wave with a duty cycle dependent on the input signal will be generated. The input signal must be a decimal in between 0 and 1, and the frequency is based on which prescaler that you choose. In inverting mode, you will choose the same settings, but the difference is that an inverted signal will be automatically generated on the pin which is complementary to that which is chosen. So, to demo the block, we'll set it to non-inverting mode, and we will also set pin 5 as the PWM output pin. We will connect the triangular wave generator block to the PWM output block. This should make our pin pulsate. Now that we're all set, we can go ahead and upload it, and we'll see the results. Okay, so just as we expected, this LED right here that is connected to PWM pin 5 is pulsating. And this button over here is connected to pin 13. And so if we press this button, it should send a high signal to pin 13, which should set this red LED that is connected to pin 7 high. So let's see. Yep, just as we expected, when we turn on this, when we press this button and set pin 13 high, our red LED turns on pin 7. Now that we've gone over the logistics of the blocks, let's take a look at what happens behind the scenes and allows you to upload to the Arduino. This support package has the ability to generate code that can be compiled and then uploaded to the microcontroller. If we take a look at the target options, we can see that we need to point PLECS to the Arduino IDE installation directory. This allows PLECS to use the resources located within the installation directory in order to compile the code and then upload straight to the Arduino on the specified COM port. We can also choose to not upload code and instead just generate the code for use in our own projects. The generated code includes 3 files: main, port config, and PWM config. Those, along with setup.h, are always going to remain unchanged. These stay the same and are the core files that contain the functions and informations needed to make your PLECS model work. The rest of the files, plex.c, plex.h, and settings.h, are generated based on your PLECS model. I hope you enjoyed this month's Model of the Month video. If you would like to learn more about the ATmega328, you can access the datasheet at the link listed on the slide. If you would like to be featured in our next Model of the Month video, please submit your PLECS models to info@plexim.com for a chance to have your model displayed. For more videos and other information, please visit our website at www.plexim.com. Thank you for watching.